Hey everybody, I just wanted to give you a real quick video about what we're going to do today, which is radicals or our square roots with variables. So last week we did radicals with just constants, our numbers, our perfect squares. So we know that the perfect squares are the opposite of squaring something. So for instance, when you have the square root of 9, that is 3 because 3 squared gives us 9. So the radical and the square root of 2, because it also has an index of 2, cancel out. Okay, so we're doing our square roots. But now we're going to take a look at variables. So for instance, if I have the square root of x to the, let's say, 4th power. Now we know that the square root of x to the 4th is asking what squared gives x to the 4th. And that's going to be x squared, because x squared times x squared is x to the 4th. So the square root of x to the 4th is x squared. But what if I have the square root of x to the 6th? Now, a lot of times students will say, oh, well, 6 isn't a perfect square, so therefore it can't be reduced. 6 in itself as a number is not a perfect square, yes, but when it's an exponent, it's treated a little bit different. So remember, this is asking what squared gives x to the 6th. What times, oops, giving you the answer. What times itself gives x to the 6th, and that's x to the 3rd, because x to the 3rd times x to the 3rd, when it's the same base, you add the exponents, gives x to the 6th. All right, so let me see if I can erase some of this and let's go through some more examples. Okay, so here's a little shortcut that they're going to do on the actual video that you're going to watch. Anytime that you have a radical with an exponent where it's an even power, okay, so anything that's an even power, 2, 4, 6, 8, 10, so forth. Even if the number itself is not a perfect square, anytime there's an even power or if it's divisible by 2, it is considered a perfect square because we're talking about the exponents, not the actual number, but the exponent. And what I like to do, and you'll see from the video, she says divide by 2. I just say chop it in half, basically. Okay, so all the same thing. So for instance, if I had x to the 10th, the square root of x to the 10th is x to the 5th. Why? Because, whoops, x to the 5th squared, power to a power multiply gives x to the 10th. If I had the square root of x to the 100th, now you might be thinking it's 10, but be careful. Remember, as an exponent, you just chop it in half. The square root of x to the 100th is x to the 50. Why? Because x to the, I don't know why I keep doing that, x to the 50th squared gives x to the 100th. If I had x to the 20, or I'm doing y now, y to the 26th, the square root of y to the 26th, that's going to be y to the 13th. Yes, 26 as a number is not a perfect square, but as an exponent, since it's even, chop it in half. If I had the square root of y to the, I don't know, 36, that would be y to the 18. So anytime it's an even, we're just going to chop it in half. But what happens when the exponent is not raised to an even power? So like, let's say, for instance, I have the square root of x to the 9th. Now you're thinking, oh, well, the square root of 9 is 3. But remember, it's not a constant, it's an exponent, okay? So when it's an odd exponent, so notice any odd exponent, it is not a perfect square. And what's going to happen, just like we had from last Thursday, you're going to have something left over in the radical. So what we're going to do, the easiest way to simplify these is to express every odd as the highest even you can. So x to the 9th can also be expressed as x to the 8th times x to the 1st. I still have 9 x's, but x to the 8th is my highest even it can go. So it's going to be the square root of x to the 8th times the square root of x to the 1st. Well, anytime it's an even, we're just going to chop it in half. So the square root of x to the 8th is x to the 4th. And notice I'm left with one exponent or one variable left over underneath the radical. And that's how we're going to simplify. You're going to see a couple examples where there's some numbers out in front and some numbers on the inside as well. Any perfect squares come out and you don't do anything else as x to the fourth, even though it in and of itself is another perfect square, it's not underneath another radical. You just do it one time. Let me give you another one. Say, for instance, I have x to the, we'll do x to the 11th, y to the 13th. Okay, we'll do 2 here at a time. All right, so x to the 11th is an odd, so we're going to express it as the highest even we can. That's going to be x to the 10th and x to the 1st. Still have 11. Y to the 13th is going to be y to the 12th times y to the 1st, both underneath the square root. What I like to do is I like to circle my perfect squares, and they're going to come out. So a half of 10 gives me 5, because x to the 5th times x to the 5th is x to the 10th. Half of y to the 12th is y to the 6th. Those are my perfect squares. They come out. But notice I still have one x and one y left over, and that becomes my final answer. Inside your radical, everything should be raised to that first power. Anything higher can be broken down. And take a look at the second video.